So today our lesson is about the rectangle. So let's first start with something that we know, which is the square, and say that what if a square is stretched? So if we have a square and we stretch it, what happens? Are the properties the same or they are different? What properties are preserved and what properties have changed and they are not preserved between a square and a rectangle? So as you can see, if we stretch a square, it will become a rectangle, as in the figure below, A, B, C, D, it is a rectangle. So let's see, these are the properties of a square. Let's see what property is preserved, which is still the same. The first one, we are going to talk about the right angles. So if we stretch a square and it becomes a rectangle, does the angles stay right? So I'm going to use a set square and put it, for example, on angle A, and you can see that angle A is still a right angle. Okay, so you can do the same for angles B, C, and D, and you can see that they are still right angles. So the first property, it's still preserved that the angles are right. The second property, for equal sides, and we can see from the figure directly, and even without using a ruler, that one side is being stretched, which is AB, it is now longer than AD. So for equal angles, or for equal sides, so no, it's not correct, it is not preserved. So the third property, equal angles. I'm reading wrong. Equal diagonals. Okay, so the diagonals AC and BD, are they still equal? Because in a square they are equal. So let's say in a rectangle. So AC, I'm going to use a ruler and see that AC it's about 6.6 or more than, with a little bit, so it's between 6.6 and 6.7. So you can see that AC is in that measure, and let's measure the side, the other diagonal, which is ADB. Also it is 6.6. so yes, the diagonals are equal. So it is a property for a square and a rectangle. Perpendicular diagonals. In order to check if the diagonals are perpendicular, of course I'm going to use a set square. Let's say the angle COD, it's the angle between the two perpendiculars. Let's check. Of course it is clear that it's not perpendicular, but I will use a set square to ensure that. So here it is not perpendicular, it's less than 90. So this property, it is not preserved, so the diagonals are not perpendicular in a rectangle. And finally, the diagonals bisect each other. Bisect each other means that they intersect at their midpoint. So here the diagonals AC and BD, they intersect at a point O. So let's check if O is the midpoint. If O is the midpoint of DB, as well as O is a midpoint of AC, then they bisect each other. Let's see. We are going to use a ruler and measure DB, which is about 6.6, as we have said, and or 6.7. So it is between those things, and the half 6.6 divided by 2, it will be or 6.7, it will be 3.35, يعني between 3.3 and 3.4, somehow in this range. So you can see that O here, it is between these two numbers. So yes, O is the midpoint of DB, and if we move the ruler to the other diagonal, which is AC, and let me adjust it to AC, it should be also on the midpoint. So it is 6.6 or 6.7. So here it is, yes, O, it is between, it's approximately 3.3 or between 3.3 and 3.4. So yes, the diagonals, O is the midpoint of AC and O is the midpoint of DB, then yes, the diagonals bisect each other. So you can see some properties are the same and some properties they are not the same for a square and for a rectangle. So let's move on. Here is a comparison between the definition of a square and that of a rectangle. You can see that a square is has more properties. So a square is a quadrilateral with 4 equal sides and 4 equal angles, but a rectangle is a quadrilateral with 4 equal angles. So no 4 equal sides because it is stretched. One side is greater than the other. And a general note that the sum of angles in a quadrilateral is 360. So it either a square or a rectangle. So this sentence, this fact applies for all quadrilaterals. Their sum of the angles is 360. So if we add angle E plus angle F plus angle G plus angle H, which is 90 plus 90 plus 90 plus 90, it will be 360. Okay, and if anyone asks you, for example, like it happens in books like riddles, if you have a quadrilateral with 4 equal angles, what is this quadrilateral? What would be the answer? So probably I would expect that some of you would answer, the answer will be it is a square and it is a rectangle, and I don't know which one of these is it. So in fact, the correct answer, it is a rectangle. Yes, true that a square have 4 equal angles, but it's not enough. If we know that a quadrilateral have 4 angles, and I stop, full stop, 4 angles, and that is it. That's the given you have. So you are sure that it is a rectangle, but you are not sure enough that it's a square, because a square, it is have 4 equal angles and 4 equal sides. So it needs more given to make sure that this quadrilateral is a square. So whenever I tell you, or a question asks you, if you have a quadrilateral with 4 angles, you are sure that it is a rectangle, but you are not sure if it's a square. Maybe if they give you more information that 4 equal angles and 4 equal sides, then yes, it is a square. Okay, now moving on. So what are the properties of a rectangle? Properties of a rectangle, they are opposite sides are parallel and equal. So what are the opposite sides? The opposite sides in this figure, MN and PO, these are the opposite sides. Okay, so if I want to, for example, mark them in green, these are the four, the first pair of opposite angles, and of course we have another pair which are MN. The second pair is MN and NO. This is the second pair of opposite sides. So two pairs, MN and PO, and the second pair MP and MN and NO. Sorry. They should be parallel and equal. All angles are right. So angle M, as you can see, and angle N, angle O, angle P, they are all right, meaning their measure is 90 degrees. All diagonals are equal and bisect each other. So the diagonals MO and NP, they are equal and bisect each other. And as we have established that bisect each other means they divide each other equally, or they intersect at their midpoint. You can see that we have more coded properties on this figure. You can see these two signs here and two signs here. They are equal not just because it's a rectangle, but more because let's name this, for example, A. Okay, so MA, if this point here we call it A, MAP equals to NAO because they are vertically opposite angles. Okay, so it's not just a property for this particular rectangle, but any angles which have the X shape, you know, they are a vertically opposite angle. So this angle is equals to this angle, and this is equals to this angle. Okay, so we have a note here that the perpendicular bisectors of the sides are axes of symmetry. So what is a perpendicular bisector? In order to draw a perpendicular bisector, of course, a perpendicular, meaning we should draw something using this set square, which is it has an angle 90, and bisector of the side means it cuts the side in half, so at its midpoint. So we can see that we can of course measure EF and mark this is the midpoint of EF, and using the set square we draw a perpendicular at this midpoint. So the perpendicular at a midpoint, so this green line is called a perpendicular bisector because it's drawn as perpendicular on the midpoint. So for example, if it were perpendicular here on this point, for example, it's called only a perpendicular, a line perpendicular to EF. But exactly on the midpoint, this green line will be called perpendicular bisector. So this perpendicular bisector is the axis of symmetry, meaning that E is the symmetry of F with respect to this green line. Let's name it, for example, D. Okay, so E is the symmetry of F with respect to D. So the perpendicular distance from E to D is equal to the perpendicular distance from F to D. They are, maybe someone can imagine it like a mirror. So D is the mirror, and the distance from E to this mirror is equal to the distance from F to this mirror. And also H is the symmetry of G with respect to this line D. Okay, and also this applies for all the sides. So if we draw here the perpendicular bisector, I'll draw it quickly, of this side, so at the midpoint, and draw a perpendicular, and also for this side and also for this side, they will be the perpendicular bisector, they will be the axis of symmetry of the rectangle. Okay, moving on. So this is a table showing the differences, comparison between the properties of a square and that of a rectangle. I marked in purple the differences. So you can see that a square has more properties than a rectangle, and they are marked in purple. So all sides are equal in a square, which is not found in a rectangle, and regarding the diagonals, they are perpendicular in a square but not in a rectangle. So a rectangle have opposite sides are parallel and equal, all angles are right, which is found in both, and the diagonals are equal and bisect each other only, whereas in a square the diagonals are equal, perpendicular, and bisect each other. Okay, so you can see that in a square the opposite sides are parallel and all of them are equal, but in a rectangle only the opposite sides are parallel and equal. So that's it for the properties of a rectangle in comparison to that of a square. And now how to prove a rectangle. So in order to prove a rectangle, we have four different ways. So if one of them is correct, not exactly the four of them should be true. If one of them is true, then it is a rectangle. So let's start with the first one. So if the three angles are right, if we can prove, or we have a given that the three angles are right, then it is a square. It's a rectangle. So for example, if we have in this figure angle A, angle B, and angle C are 90-degree angle, we know that it's a given that they are 90-degree angle, we are sure about it, then this is a rectangle. And we do not need to show or to prove that angle D is 90. Why? Here it is why. I wrote them here. So we know that the sum of the angles is 360, and if we have proven that three angles three angles of those four are 90, so 360 minus 90 plus 90 plus 90, because we have proven that three angles are 90, the answer will be 90. So we are sure that the fourth angle is right, whether we prove it or not. So if three of them is 90 degree, then of course the fourth one will be also a right angle. So this is the first method. So if this method is correct, then the quadrilateral is a rectangle. And if we have no given regarding the angles, we can move on to the second way, which is about the sides. So if the opposite sides are equal, and we have agreed that we have two pairs of opposite sides. So this is the first pair, AB and DC, and the second pair is AD and BC. So if both of them, so if AB is equals to DC and AD is equals to BC and one right angle, so any right angle, A or B or C or D, if all of these conditions are correct, then it is a rectangle. If of course we have a given regarding that they are equal. If we do not have that they are equal, but we have that they are parallel, then this is true also. So if we have AB is parallel to DC and AD is parallel to BC and one right angle, so also it is a rectangle. So I repeat that one of them should be correct, not all of them. So either we have a given about the three angles, or we have given about sides, which sides are equal to which sides, or we have given about if they are parallel or not. And if we do not have given about all of them and we have given about the diagonals, we also can prove a rectangle from its diagonals. If we have given that the diagonals are equal and bisect each other, then this quadrilateral is a rectangle. So that's all for our rectangle, and in our next videos we will solve some exercises.